Welcome to yet another screencast in section 2-1 of Math 2 Lawrence Academy Math 1 course. We are going, as you can see, to dabble with basic angle definitions, and let me expand this out for you slightly. There we go. So, here we are. Basic angle definitions. I'm going to take you through that today, and I'm sure you'll derive some enjoyment out of the screencast, and hopefully you'll pay attention and follow along. Here we go. So to start with, we're going to just define an angle bisector. So not an angle, but an angle bisector. So here it is. A ray that cuts an angle into two equal angles is how we define an angle bisector. So let me take a look here and show you what we mean by that. So if we have angle, let's call it A, B, C. Angle ABC right here. And we cut that angle in equal halves with ray BD. And this again is just eyeballing it. We can create congruent angles. We used the word congruent in the previous section. And I can represent that with a hash mark here and a hash mark here. Written out, I can call this angle, I can write A, B, D is congruent, remember that equal symbol with the tilde, to angle D, B, C. So leads us to our next definition, congruent angles. We just defined it above. So take 1 second here and pause the screencast and define congruent angles for yourself. So that is correct. Two angles with the same angle measure we can call congruent. And if you look above, angle ABD is congruent to DBC because of the hash marks that we've displayed. Ray BD is the angle bisector of angle ABC. Moving on to the next, we're thinking about a right angle. So again, pause and come up with a definition for a right angle. Now, what was that? Are you mulling it over? I think I heard somebody. What did you say? That's it. That's correct. Very well done. A right angle is an angle that measures 90 degrees. And we can represent it the following way here. I will take my trusty writing utensil and draw out a triangle here. If you look at A, B, and this line segment AB and line segment BC, they are what we refer to as perpendicular, and we represent the 90-degree angle with this little box. This would be 90 degrees. I'll be right back with the definition as we lift it up into its spot. So here it is. Right angle is, again, an angle that measures 90 degrees. Next one we're going to look at is an acute angle. So pause the screencast and think about it for a minute. What is an acute angle? That is absolutely correct. You guys are so smart. An acute angle is an angle that measures less than 90 degrees, and we can represent that right here with our trusty writing utensil the following way. We will take vertex B and extend it out to point C, creating that ray BC. You learned that in the last section. And then we'll go from vertex B out to point D. And we've now created angle CBD that is less than 90 degrees. Let's call it 30 degrees. If I were to draw in a dotted line here to represent the 90-degree angle, we would know that the difference between the 30 degrees and the 90 degrees is 60 degrees. So both 60 degrees and 30 degrees are acute. Actually, let me just label this point up here, make it a little easier for you to notice it. And if we look at angle ABC, it's 60 degrees, and angle CBD equals 30 degrees. Those are, class, acute angles. Next up, obtuse. Think about it for a second. Pause your screencast. So no, an obtuse angle isn't something that's odd or out of the ordinary. It is an angle that measures greater than 90 degrees, and it's less than 180 degrees. Let me bring it over here like that because the degrees was running off the page. So we could draw it like such. Have the vertex, call it B, have this point A and this point C, and the distance from, or the segment, or ray BC to ray AB would be a degree measure of, let's say, 120 degrees. So we've extended, if we put in a 90-degree angle here, call that angle DBC, we notice that that's angle DBC equals 90 degrees, and angle ABD would equal the difference between 120 and 90, which is 30 degrees. So angle DBC plus angle ABD would be 120 degrees, creating your obtuse angle. And we can write it out like this. A would be 90 degrees plus 30 degrees equals 120 degrees. And of course, you could label the obtuse angle angle ABC. And there it is. Next up is the definition for vertical angles. Think about that. So this definition is slightly more complex. Vertical angles are two angles formed by two intersecting lines that share a common vertex but not a common side. Right here is the definition. To draw that out, we could take two intersecting lines. Whoops. Here we go. So call that line AB and call this line CD. Oops. Let me adjust that. C and D right here. So if we look at the vertical angles here, we could say that angle, would help to put in the vertex, wouldn't it? Oh boy. So E, there we go. So angle AED and angle CEB are vertical angles. All right, next up we have the definition for a linear pair of angles, which is going to lead us into the nitty-gritty of all these basic angle definitions. So two angles that share a common side, a vertex, and their non-common side form a line is our definition for linear pair of angles. So this definition may sound a little complex, so let's draw it out. If I take my straight line, whoops, been doing that a lot lately. Call that straight line AB. And I put in ray, call it CD. I've now created angle 1 and angle 2. So as far as the vertex that they share, it would be this point here, C. So that's their vertex. And in terms of their common side, well, CD, ray CD would be the common side. Common side. And then for angle 1, you'd have line CB would be the non-common side that forms that line. And then for angle 2, you'd have line AC. That forms the non-common side. So We have here in angle 1 and angle 2 a linear pair of angles. Next up will be complementary angles. So pause the screencast and think about what a complementary angle means. By golly, that is correct. Complementary angles are angles whose sum is 90 degrees. So here's the definition. And again, we can take out our writing utensil and do a diagram for you. So let's take a base here, flat line, and horizontal line I should say, and take a perpendicular line. Perpendicular meaning that the two line segments meet at a 90-degree angle. So we can call angle, and then we'll put in a, it's not an angle bisector, because that would split the angle in half. We're just cutting the angle here into two different angles. So call this angle 1 and angle 2. We know that angle 1 plus angle 2 must equal 90 degrees. Therefore, they are complementary. So now I want to define a pair of supplementary angles. And the definition is two angles whose measures add up to 180 degrees. Again, draw this out, and we could say that angle, let's say ABD and angle ABC are supplementary. Angle ABC plus angle ABD equals 180 degrees. Now you'll ask, why is that? Well, we know that the degree measure of a horizontal line is 180 degrees. Therefore, when we add in ray AB, we create the two angles ABC and ABD. And we'll call that 1 and 2, and they must add up to 180 degrees. Therefore, the two angles are supplementary.